Hi everyone, welcome to this workshop. Today we practice on solving compound inequalities. So first of all, let's go over find the intersection and the union of two sets. So we have two definitions here. The intersection of set A and set B, written as A intersect B, is the set of all elements that are common to set A and set B. So we need to see that the intersection would be written as A intersects B, and the intersection of set A intersects B is all elements that are common to set A and set B. So that's our common to set A and set B. We will talk more about this in the example. So the second definition is the union of set A and set B, written as A union B, is the set of elements that belong to set A and set B or both. So union of set A and set B, be written as A union B, is all the elements that are belong to set A or set B or both. So basically it sounds like we take all of them. Whatever we have, we take all of them. So we have the example here. The problem is let A equal the set of element 0, 1, 2, 3, 4, 5, 6, and B is the set of element -4, -2, 0, 2, and 4. And in problem A, they ask you find the A intersects B, and problem B is find A union B. So the way to solve this one is we have to use the Venn diagram. Venn diagram. How does it look like? Basically, we make two circles, make two intersection circle. So name this one as the first circle stand for A, and the second circle stand for B. Then I will fill in the middle where the intersects at the number has the common on both terms. The number is common in both terms is we have 0. We have 0 from A and also on B. Okay, we have 0 in common. Really? So in example 1, we have let A equal to 0. Example 1, we have let A is the set of 0, 1, 2, 3, 4, 5, 6, and B is the set of elements -4, -2, 0 to 4. So problem A, they're asking you find A intersects B, and problem B, find A union B. The way to solve this one, we have to use the Venn diagram. So basically you have to do is draw two big circle, two intersection circle. Okay, this and that's two intersection circle. So name the first circle is A. Say this my what's color. So I use A for this one and B for the circle. Okay, so my next step is find out the common term on both of them. So let's say 0 in A and 0 also in B. So I'm going to circle this. 0 is the common term. Okay, 1, we don't have 1 in B, but we have 2 in both. So 2 in A and also 2 in B. Okay, and we also have 4 in A and 4 in B. Okay, so we have one pair of 0, one pair of 2, one pair of 4. So I will fill them into the intersection area, which is right here. So we have one pair of 0, one pair of 2, and one pair of 4. So we write as a pair. We don't write 2, 0, and 2, number 2, and 2, number 4. We just write 0, 2, and 4. So in set A, we still have elements left over is 1, 3, 5, 6. So at the circle A, so we fill in 1, 3, 5, and 6. And in set B, we still have -4 and -2 left over. So I will fill in -4 and -2. So in problem A, they give you A intersects B. So A intersects B is right here. We have 0 to 4. So A intersects B. So we have A intersects B equal to, the element is 0 to 4. So I fill in here 0 to 4. This is my answer for A intersects B. And in problem B, we have A union B. So A union B, the union is all the elements that belong to set A and set B, or both belong to set A or set B, or both. So basically we take all of them. We take all the elements, that is my A union B. We take all possible number. So we have A union B equal to, so we take all the numbers, so I just filled it. It's nicer when you write the small number first, so we'll go with -4, -2, then 0, 1, 2, 3, 4, 5, and 6. So intersection, after we draw the Venn diagram, where they in common on both A and B is my intersection. And union, basically we take all the number from the Venn diagram, not from A plus B. If you use A plus B, then you have 2, 0, 2, 2, and 2, 4, which is not correct. So use the number from the Venn diagram. So cell check. Now it's your turn to practice on what we just learned. So go ahead, do the cell check. You have 5 seconds to pause the video before you see the answer. So I believe we all have the answer. I will hold on to the answer part. I don't give you the answer yet. Let's go through this one to make sure you understand the concept. So we use the Venn diagram again for this problem. Venn diagram. So what we're gonna do is make 2 big circles. Oops, it's supposed to be a circle like this, and also this one here. So I named this one as first one is my circle C, and second one is my circle D. So our next step is find out which number is common in both. So we have A and C, but there's no A in D, and 9 in C and also 9 in D. So I'm gonna circle this. This is my first pair. Okay, 9. 10 in C, but not in D, and 11 in C, but not in D. So just only 9 in common between C and D. So in circle C, we have left over is 8, 10, and 11. So I fill in here 8, 10, and 11. And in circle D, we still have 3, 6, 12, and 15 left over. So I bring it here, 3, 6, 12, and 15. So on problem A, we find C intersects D. So just only one element where is C intersects D. So C intersects D, the 9 is the only element where C intersects D. And the second one is C union D. So C union D, again, basically we take all elements. So C union D. So we have small number first. So 3, 6. Let's say next one is 8, 9, 10, 11, 12, and 15. And that's the answer for the cell check. So we just have some idea about intersection and union. So now let's move on to the next problem, solving compound inequality containing the word and. So N is stand for the intersection. So intersection is stand for N, or later on the graph we will see the overlap is also stand for N. So you should write this down somewhere or highlight it. So that's really important note here. So in example 1, we have x divided by 2 plus 1 greater than 0 and 2x minus 3 less than 5. So we're going to solve each individual inequality, and we combine them later on when we graph both of them in the same real number line. So in the first inequality, we see fraction. So I can do is multiply all three terms by 2. So multiply by 2 for fraction, for 1, and also for 0. So when you do that, 2 and 2 will be cancelled out, give you with x plus 2 greater than 0 times 2 give me 0. Then we're going to do next is isolate the x, subtract 2 on both sides. So we will have x greater than 2 negative 2. Okay, and on the right hand side, we don't have fractions, straightforward, just isolate the x. So add 3 on both sides. We will have 2x less than 8 and divide both sides by 2. So we will have x less than 4. Now let's graph this one. We have to graph both of them in the same real number line. So negative infinity, positive infinity. Since we practice a lot with a linear inequality, so I just go straight forward to the tip where I tell you the arrowhead method. So we're going to do is mark 2 points. So we have two solutions, negative 2 and 4. So negative 2 is the smaller number, so negative 2 go first, and 4 is the larger number, so 4 goes second. Then we use the arrowhead method. So put the tail for the inequality at negative 2. So this tail will be point me go to the right. So at negative 2, I will make the arrowhead go to the right without the equal sign, so that will be a parenthesis. Okay, and at 4, put the tail at 4. So this 4 point me, let me use a different color. So at 4, I put the tail. That is point me go to the left instead. So go to the left. Make sure you draw the arrowhead all the way through. Don't stop at the middle. Go all the way through. So as we see that with the letter N right here, we're looking for the overlap. Okay. We're looking for the overlap. So for this graph, the overlap from negative 2 to 4. So that is my answer is. So again, straight out from the graph, so parenthesis, negative 2, comma 4, and close parenthesis. And that is our answer for example 1. So the only thing we need to remember in this case is N is stand for overlap. We're looking for the overlap. Now let's go over one more example. So we have example 2 is x plus 3 less than or equal to 2x minus 1 and 3x minus 2 less than 5x minus 4. So we're going to do is bring the variable to one side. So subtract 2x on both sides. Then you will have the negative x plus 3 less than or equal to negative 1. And keep going, isolate the x, so minus 3 on both sides. We will have negative x less than or equal to negative 4. And get rid of the negative x by divide by negative 1 on both sides. So again, divide by a negative number, we have to flip the inequality sign. So to the opposite one, we will have x greater than positive 4. Okay. So on the right side, the same concept, so subtract 5x on both sides. We will have negative 2x minus 2 less than the negative 4. and add 2 on both sides. We will have negative 2x less than negative 2 and divide by negative 2 on both sides. So which will give me this is negative, so I need to put this to the opposite one. Give me x greater than positive 1. So to give this answer in interval notation, I have to do is draw them out. So make a real number line, negative infinity, positive infinity. So we have 1 and 4, so mark 2 points. 1 is the lowest number, so 1 go first, and then 4. So use the arrowhead method I show you. So F1, I put the tail for the inequality sign. So F1, they point me go to the right. So we go ahead go to the right with parenthesis. Okay. And at 4, here my 4, let me use a different color here. This would be one here. So at 4, put the tail for inequality. That point me go to the right as well, and with the equal sign we will use the bracket. So with the n letter we're looking for where they overlap. So as you see on the graph, they overlap at 4 and go all the way to positive infinity. So my answer would be bracket 4 to positive infinity. 4 go to positive infinity. Subject part. So now it's your turn to work on the problem. So I have 3 problems for you. Go ahead and work on that. If you get stuck, go back to the example and make sure you understand the concept. As long as you know what to do and what does AND stand for, you will be fine. So the answer for problem 2 is a little bit different. So, but if you understand the AND, you will be fine. Okay, so you have 5 seconds to pause the video and working on this. So I believe you have your answer already. So let's go over 3 problems to see do we have the same answer or not. So problem 1, we have 3x greater than negative 18 and x divided by 5 minus 1 less than or equal to 1. So we're going to solve the first inequality first. So I'm going to do is divide both sides by 3. We will have x greater than negative 6. So as you see, even the right side we have the negative answer, we still don't flip the inequality sign. Keep in mind, we flip the inequality sign when you divide or multiply by a negative number. Since we just divide by a positive, the inequality sign stays still. Okay. So on the right side we have x divided by 5 minus 1 less than or equal to 1. Since we have fraction, we need to get rid of fraction. So the LCD in this case is 5 because 5 divisible by 5. So multiply by 5 on 3 terms. We will have this 5 will be cancelled out. That's our goal, to cross out the bottom. So we have x minus 5 less than or equal to 5. And keep going, isolate the x, so add 5 on both sides. We will have x less than or equal to 10. And to write this answer in interval notation, I need to put both of them in our real number line. So negative infinity, positive infinity, mark 2 points, one for negative 6 and the other one for 10. Negative 6 go first because the smaller number. So next step is we put the arrowhead in. So put the tail for inequality at negative 6. That point me go to the right. Okay. And without the equal sign, I will use the parenthesis, which means not include negative 6. And at 10, I put the inequality sign for 10. So that point me go to the left. So I will go to the left. And with the equal sign, then we will use the bracket for this. Okay. So with the M problem, we're looking for the overlap part. So they overlap from negative 6 to 10. negative 6 to 10. So my answer is negative 6 to positive 10 with the bracket. Now in problem 2, we it's straightforward, no fractions, so go ahead isolate the x by add 1 on both sides. Then we have x, we will have x greater than negative 2. And on the right side, we just need to divide by 2 on both sides. Then you will have x less than negative 4. And we put both of them in our real number line. Negative infinity, positive infinity. So negative 4 and negative 2. Negative 4 is smaller, so negative 4 go first, then negative 2. At negative 2, I would put the tail for inequality. That point me go to the right side without an equal, so it would be parenthesis. And at negative 4, let me see. At negative 4, I put the inequality, I put the tail for negative 4. That point me go to the left, so we're going to go to the left. Without an equal sign, that will be a parenthesis as well. So again, we deal with the end problem, so we're looking for where the overlap. Since the graph don't have the overlap part, so the answer would be no solution. No solution. So on problem 3, we have 2x plus 3 less than 4x plus 2, and 3x plus 1 less than 5x plus 3. So let's solve the first inequality first. We need x stay on one side, so subtract 4x on both sides. We will have negative 2x plus 3 less than this be cancelled out, less than positive 2. Then isolate the x, subtract 3 on both sides. So negative 2x less than negative 1. Then we divide both sides by negative 2. Divide both sides by negative 2. And don't forget negative divide by negative number, we flip the inequality sign. So we have x negative over negative give me positive 1/2. Okay. In the second inequality, we have 3x plus 1 less than 5x plus 3. Do the same concept, so move x to one side. We subtract 5x on both sides. And that will give me negative 2x plus 1 less than positive 3. Then keep isolate the x, subtract 1 on both sides. Give me negative 2x less than 2. And divide by negative 2 on both sides. And one more time, we divide by a negative number. So we flip the inequality sign, go to the opposite one, and you have x greater than negative 1. Now let's put both of them in the same our real number line and see what do we have. Put the same number line, so we have mark 2 point 1/2 and negative 1. Since the negatives is definitely less than a positive number, so negative 1 go first and then 1/2. Then we put the tail for the inequality sign for 1/2, so that point me go to the right with the parenthesis at 1/2. And we put the inequality sign, the tail for this inequality, that's also point me go to the right. So we go to the right, and without equal, that will be a parenthesis as well. So since they overlap at 1/2 to all the way to positive infinity, so my answer would be positive 1/2 go to positive infinity, and that's the answer for problem 3. Now let's move on to the next section. So in this section we will practice on solving compound inequality contain the word or. So as we see, N is stand for the intersection or overlap. So in this case, we have or is stand for the union, or in this case, I would say is take all possible solution. Take all possible solution. Solution. So what does that mean? When we solve the example, you will see it's more clearly what I'm talking about. So example 3, we will solve each inequality first, and we see that in this case they connect by the or letter, not the and letter. So first of all, we have to deal with fraction, and we know that to get rid of fraction, multiply both sides by the LCD. So LCD in the first inequality is 3, so we're going to multiply 3 on both sides. So this 3 will be cancelled out, and also on this side, left us with x greater than 2. Pretty much easy. That's the first inequality, the answer for the first inequality. And in the second inequality, we have negative parenthesis x minus 2 and close parenthesis greater than 3. So we're going to do is distribute the negative sign, or you can think we have the negative 1. Then we're going to distribute that negative 1 into the parenthesis. So which will give me negative x plus 2 greater than 3, and isolate the x by subtract 2 on both sides. We will have negative x greater than 1, and divide both sides by negative 1. So we are dividing by a negative number, so we're going to flip the inequality sign. So it's give me x less than negative 1. Now we will put both of them in number line. So mark 2 point. Negative 1 go first, and then 2. Put the tail for add the 2, so that point may go to the right side with the parenthesis. And put the tail for the negative 1 inequality, so that point may go to the left. So when we deal with the end problem, if they go to the different direction, there's no overlap, so it's no solution for the end problem. But in this case, with the OR, we will take all possible solution. So the possible solution I'm talking about is any number less than negative 1, we will take them. So it starts from negative infinity to negative 1, and union to connect the second part, any number greater than 2, so parenthesis 2 to positive infinity. So we take all possible solution, and that is my answer. Subject part. So I have 2 problems for you to work on. Go ahead and work on that one. If you get stuck, go back to the example. Or and N is pretty much exactly the same, except the final answer when after you graph them on the number line, we have to find out. With the N, we need to find out where they overlap. With the OR, we take all possible solution. We take all the solution we have. Alright, you have 5 seconds to pause the video and working on those 2. Alright, I believe you have your answer already. So let's go over each problem and see do we have the same answer or not. So the LCD, the first inequality, we need to get rid of fractions. So the LCD for that one is 2. So we multiply both sides by 2. The goal is cross out the bottom. So we will have x greater than 4. And on this side we have negative 3 times x minus 2 greater than 0. So what we're going to do is distribute the negative 3, which will give me negative 3x plus 6 greater than 0, and isolate the x, subtract 6 on both sides. We will have negative 3x greater than negative 6, and we divide by negative 2 or negative 3 on both sides, and that will give me x. Since we divide by a negative number, so again flip the inequality sign to less than, then negative 6 divided by negative 3, that will give me positive 2. Positive 2. Now we put both of them in number line. Negative infinity, positive infinity. We have 2 and 4, so 2 go first and then 4. Again, apply the arrowhead method, put the tail for the inequality sign, that point may go to the left, so we're going to go to the left with the parenthesis. And at 4, put the tail for inequality. That point may go to the right. So, and without the equal sign, that will be another parenthesis. So with the OR problem, we take all possible solutions. So we will start from negative infinity to 2, close parenthesis, union, open parenthesis for 4, and go to all the way to positive infinity. And that's the answer for problem 1. Now on problem 2, we gonna solve each inequality. This one gonna do is subtract 3 on both sides. So we will have x greater than or equal to -6. On the right side, we need to get rid of this negative, so divide by -1 on both sides. And again, I keep reminding you, anytime when we divide by a negative number, flip the inequality sign. So that is really important. If you get wrong answer, most of the case it's because we forget to flip the inequality sign. So 0 divided by -1 will give me 0. Now we put both of them in real number line. So mark 2 point, -6 is smaller than 0, so -6 go first, then 0. So put the tail at the inequality at 0. That point we go to the left. That point we go to the left. That point go to the left. And -6, put the tail for inequality at -6. That point we go to the right. And with the equal sign, that will be a bracket. And I missed the 0 part. So at 0, without equal sign, that will be parentheses. So keep in mind that we're dealing with the OR problem. We take all possible solutions. So any number less than 0 has been covered, and any number greater than -6 has been covered. If you look at this graph, we cover every single solution from the negative infinity to positive infinity. So my answer will be negative infinity to positive infinity for problem 2. So now this is the last section for this solving compound inequality. Right now we solve the double linear inequalities. So we have example 4, -3 less than or equal to 2x plus 5 less than to 7. There's 2 methods to solve this one. Let's go over method 1 first. Method 1. So method 1, we solve this one by keeping all 3 sides of the inequality. So let me rewrite this. Okay, so we have total 3 sides or 3 parts of this inequality. That's the first part, the one in the middle, and the one in the back. So there's 3 parts. I want to isolate the x. I want x stay alone by itself in the middle. So first of all, we need to move 5 out of the middle by subtract 5 on all 3 sides. So by subtracting 5, you will have -8 less than or equal to 2x less than to positive 2. Then keep going, isolate the x. Right now it's 2 times x, so we're going to do is divide by 2 on all 3 sides. So we will have -4 less than or equal to x less than 1. To graph this one out, I will draw the number line, negative infinity, positive infinity, and we have -4 and 1. So as we see that x in the middle, x from -4 to 1 with the bracket 4, because you have the equal sign as -4. So it's a bracket at 4 and parenthesis as 1 and x in the middle. So our answer is from -4 to 1 is the answer. But I don't like the method 1 much because it's not always x. It looks like x between -4 and 1, but sometimes it's not. You have to double check by cover the x. make sure they give you the true statement. Let's say I cover my x, so one we have 1 greater than -4. That's the correct statement. That's the correct statement. That's why the solution does make sense, x between -4 and 1. But in some case, if you forgot to check, you will get the wrong answer. So now let's go over this problem by method 2. Um, to solve this by method 2, the idea is we will cover one side of inequality of this double linear inequality. Let's say, look in the problem. I'm gonna cover less than 7. Then we have -3 less than equal to 2x plus 5. So we're gonna copy that one down. -3. We're copying down -3 less than equal to 2x plus 5 as my first inequality. So I have that one down. Then the next one we cover on the left side. So I'm gonna cover the left side of this problem. Cover the -3 less than equal to. Then we will have 2x plus 5 less than equal to 7. 2x plus 5 less than to 7. Basically, you cover the right side to get the first inequality and cover the left side to get the second inequality. And we have to connect two inequality by the letter n. Always, if you have three sides you break down at two inequality, always connect them by the n letter. Now we will solve each of them. So the left inequality, we're gonna isolate the x by move 5 over, subtract 5 on both sides. That will give me -8 less than equal to 2x. Then we divide both sides by 2. That will give me -4 less than equal to x. Since we always want x stay on the left so that I can apply the arrow hat method, so I'm gonna mirror the whole thing or reverse the whole thing. X greater than equal to -4. Okay. Now on the right side, isolate the x by subtract 5 on both sides. We will have 2x less than 2, and divide by 2 on both sides. We will have x less than 1. Now we're going to graph this one, make the number line -infinity, +infinity. So we practiced with this problem a lot before. So I will go quick on this. So -4 go first and then 1. Put the inequality sign after at the -4. That point we go to the right with the equal. That will be a bracket. Okay. Now at 1 I put the inequality sign. That point we go to the left. So keep going, go to the left. And that not a good drawing. Go to the left, and we use the parentheses to connect them. Now with the n letter, we're looking for the overlap part. We're looking for the overlap. So they overlap at -4 to 1. So my answer is -4 to 1. So this method has their own advantage. I believe this one was better than method 1. First of all, because we practice a lot with this type of problem. And the second thing is we know what to do. We know we're looking for the overlap. The other one, you have to make sure the statement is true to say x between -4 and 1. Subject part. So I have two problems for you to work on. If you get stuck, go back to the example. Make sure you understand the concept. You can solve either method 1 or 2. They still give you the same answer. So you have 5 seconds to pause the video. Then we will talk about this after you're done. So I believe you already have your answer. So let's check, do we have the same answer? So as I say, I'm gonna solve this one with method 2 um, in most of the time. So we're gonna do is cover the right side. I will have my first inequality is -3 less than 2x minus 5, and now we cover the left side. You will have 2x minus 5 less than equal to 9. Now we solve each inequality. So add 5 on both sides, then we will have 2 less than 2x, and divide by 2 on both sides. We will have 1 less than x. See, now 1x stay on the left. I'm gonna reverse the whole thing. So 1x greater than 1. And on the right side, move 5 over. So we have 2x less than equal to 14. Then we divide by 2 on both sides. Then x less than equal to 7. Now we put both solutions in the number line. Negative infinity, positive infinity, mark 2.17. So at 1, they go to the right with the parenthesis, and at 7, so that point may go to the left with the equal sign, so we have the bracket at 7. So they are overlapped at 1 and 7. So 1 and 7 is my answer for problem 1. So on problem 2, we're gonna do the same thing. Cover the right side, you will have 0 greater than equal to 1/2 x minus 4. And we cover the left side, you will have 1/2 x minus 4 greater than to 6. So we have fraction. The first inequality will be solved by multiply the whole equation by the LCD, which is 2. So 2 and 2 will be cancelled out. Give me 2 times 0 is 0 greater than equal to x minus 4. So we isolate the x by move 4 over. So add 4 on both sides. 0 at 4 still give me 0 greater than equal 0 plus 4 give me 4. Excuse me on that. Give me 4 greater than equal to x. Then we're gonna reverse this one. We will have x less than equal to 4. Now on the right side, we're gonna do the same thing. So LCD is 2 because we just have only one denominator, which is 2. So multiply everything by 2. So this cancel out with that 2. So give me x minus 8 greater than positive 12. Then we isolate the x at 8 on both sides. So x greater than 20. Now we're gonna graph this one. So put them on the number line, negative infinity, positive infinity. So we have 4 here and 20 here. So at 4, that point may go to the left with the equal sign. That will be a bracket. And at 20, that point may go to the right and with the parenthesis. So with the M letter, we're looking for overlap. Since this graph doesn't have any overlap part, so the answer would be no solution. No solution. Okay, if you solve method 1, you probably don't see this case happen if you didn't cover x in the middle. And if you do that, you will see, if you cover x in the middle, you will see that 4 greater than 20 doesn't make sense with this false statement. That's why it's also no solution. Extra practice, I have 8 problems for you to work on. Go ahead, work on them. If you get stuck, go back to the example and self-check. You have 5 seconds to pause the video before the answer show on the screen. So I believe you have your answer. I hope that we all get correct answer. If you get stuck, just go back to to the example. Okay, make sure you understand the idea between or and and as always, thank you for watching and see you in the next video. Bye bye.